Okay, this is section 7.6, and we want to look at this idea of center of mass through the idea of the moments. And let's just start with, suppose I know I have, set out a number line or something like that, and I'm going to put my balance point right here at the origin. Okay, so that's 0. And I'm going to have some x1 here to the left where I'm going to put mass 1, and I'll have some x2 out here to the right where I'm going to put mass 2. And if 0 there, if the origin's really a balance point, well, then we know this distance times m1 has to be the same as that distance times m2. Okay, so what's this distance over here? Well, it's since x1 is a negative number, it's actually the absolute value of x1. So if 0 here again is the balance point, then it must be that m times the absolute value of x1 is equal to m2 times x2. I don't need absolute values there because x2 is a positive number. Okay, now what is the absolute value of x1? Well, again, if x1 is a negative number, its absolute value is the negative of itself. And so what we get is this equality that minus m1 x1 has to equal m2 x2. Now I'm just going to add this to both sides and put all the stuff on this side. So m1 x1 plus m2 x2 would be 0. Yeah, I got to be careful how I said that. I said I'm going to add this. Well, what I meant was I'm going to add that to both sides. That will take care of that minus sign there. And so what we see is that if we simply add these two moments together, we got the center point. Yeah, okay. Well, let's kind of move things, and now let's have some general, x1. For now, I'm going to, let's call it x bar. I was going to call it xb for the balance point, but let's call it x bar. And, here is x2. And these are just somewhere on the number line. And I have m1. And I have m2. Well, again, what we know is, with these distances, that they have to be equal. So that says that m1 times the distance here, well, the distance there is what? X bar minus x1. That has to equal m2 times x2 minus x bar. And so then when we multiply through by things and all that, I can move the m1 x1 to the same side as the m2 x2, and I end up with m1 plus m2 times x bar is equal to m1 x1 plus m2 x2. Okay, and so then x bar is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Now, and so we get that balance point that same way, okay, but it ends up being this, right? Now, why didn't the M1, M2 show up, back here? Well, even if we did it the same way, right, we would have had 0 times M1 plus M2, so we still would have just had 0. So the numerator would have been 0 here. It didn't matter what the denominator was, as long as it wasn't 0. And so if we expand this idea to a bunch of objects, so here's an M1, an M2, M3, and so forth, out to some M sub n, and we wanted to do that same idea of trying to find a balance point. So here's x1, x2, x3, out to some xn. As we try to find that balance point, it would actually work the same way. We would need, from wherever that balance point is, here, say, x bar, we would need all of the moments along here to balance out with all of the moments here. So there's another property from physics that that inspires this model and so forth, is that those moments are additive that way, and so anything on the left will add to help push down the left side, and anything on the right will add to help push down the right side. And so, doing the same thing, I just have a whole bunch more of these, right? So I would have, I would do that same subtraction and solve for x bar, and I would have an m1 plus an m2 plus all the way up to m sub n times x bar, okay, just like I had m1 plus m2 there times x bar, and then equals, and I would have my m1 x1 plus m2 x2 plus all the way out to m n xn, and so x bar is the sum I equals 1 to n of the mi divided by then the sum of just the m's, I equals 1 to n of m sub I. And so that is how we get this definition of our center of mass, this x bar. Okay, and so that's kind of the physics and length interpretation. Now, another interpretation could be sort of a weighted average idea, is that, say I want the average of some numbers, right? And you all know that the idea, if I want the average x bar of, say, a set of numbers, x1 through xn, that's x1 plus x2 plus x3, up to xn, and then divided by n. Okay? Well, so you see there's something similar there. But now let's, at each, for each of these x's, let's toss in a multiplicity. So in other words, here, maybe I was saying something like x bar is equal to 1 plus 4 plus 7 plus 9, all divided by 4, and I got that number. Okay, well, what if my numbers, I had multiplicities, many of these things, and so, suppose I had 3 ones, right? So I could have an x bar that would equal 1 plus 1 plus 1, and 2 4s, so plus 4 plus 4, plus 1 7, say, and 3 9s, so 9 plus 9 plus 9. Now, what would I have to divide that by? Well, you see, I could take, there are 3 of those, 2 of those, 1 of those, 3 of those, so that's 3 plus 2 is 5, 6, and 9, so I would divide by 9. Okay, well, a little bit shorter way to write this would be, 3 times the 1 plus 2 times the 4 plus 1 times the 7 plus 3 times the 9, all divided by the 3 plus the 2 plus the 1 plus the 3, because that adds it up. Now, in a notation, if I call these numbers the multiplicities, oh, that's an m. So you see what I'm doing is I'm saying, oh, well, this weighted average, I'm going to take however many x1s there are, plus however many x2s there are, plus however many x3s there are, and so forth, right, up to xn, and divide by, well, how many numbers are there? Well, total, there are m1 plus m2 plus m3 plus dot 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 plus mn numbers. And so even if you're thinking of it, you're saying, well, x bar we use for average of a bunch of numbers, it actually still fits that definition, where you can think of the m's in this case, instead of being masses exactly, they're the number of numbers of that value x1 or that value x2. Well, in a sense, that's sort of a mass, right? Is that if I had 3 of the 1s and only 1 of the 7s, I had 3 times as many. It was 3 times as big or something like that. It's like a mass. And so these two formulas, right, this one here and this one here, are the same darn formula for this thing we call an x bar. Okay, so it's an average, and in physics terms, we call it the center of mass because it tells us a place where we can balance something. Okay, so that is our definition so far of center of mass, is right here. And so we'll go on to more things.